Hey all, today we are going to talk about quantitative data. That is data that you can measure, data that has units, and we are going to talk about how we can display and describe displays or distributions of quantitative data. The first way is through a histogram. This is probably the one that we're going to see most of the time this year. A histogram looks like a bar chart. However, the x-axis or this horizontal axis is important because we do have measures. They're not just categories here. So sometimes the bars will touch each other, sometimes they will not, like you can see right there. And that's important because these represent a measure. And then this axis will be a frequency of the number of items that belong to each bar. And I'm just going to go through some of these sort of quickly, just so you get an idea of what they look like, because we do have some calculating to do and describing. This is called a stem and leaf plot. And of course, you can ask further questions as we go. Stem and leaf plot's just a different way to display data. What's really nice about this is the individual data points are preserved. Again, this is a little blurry. I'm working on that. I apologize. But basically what we have here is a stem, and these are leaves. I'm just going to say leaf. And so each one of these leaves over here represents a data point, and we put the stem with each leaf to create one data point. So for example, this is 88, and that is 80, and then we have another 80 and another 80 and another 80 and 84 and 84 and 76 and so on and so forth. So it's just a way to display the data points, but we also preserve the data points because you can see what they actually are. In a histogram, you can't see the individual data points. A dot plot, similar to a stem leaf plot, does preserve the data points. We just put a dot for each data point to display our data set. So this is a lot of dots. This might have been probably too much to do to make a stem and leaf plot, too many leaves. And so we can just use dots. It looks like a histogram, but it shows us specifically each data point. And this is kind of turned on its side, and that's okay. You can do that. Sometimes it's shown vertically or horizontally. And I know I went through those quick, so please do ask me if you want some help or some elaboration, and we can talk about them together. The important thing is to be able to look at those types of quantitative data displays. Sometimes, or a lot of the time, we call them distributions. It shows how the data is distributed. The important thing here is to learn how to describe those distributions. And these are the main things that we want to talk about whenever we're describing a distribution. We want to talk about its shape. We want to talk about anything unusual that exists in that distribution. We want to talk about where is the center located and how spread out the data is. And we're going to elaborate on that now. And of course, I use this mnemonic. It used to be socks because one of the unusual characteristics is an outlier. But we've had to include other types of unusual characteristics, so we've changed this mnemonic to sucks. So if you can remember that, hopefully it'll help you remember the things you need to talk about when describing a quantitative distribution. So several types of shapes we might see. The first one here is approximately, nothing's perfect. There's variation in life. This one right here is approximately uniform. Uniform meaning those bars there are pretty close to being around the same height. Not exactly. That's why we say approximately. This second one is symmetric. It's approximately symmetric. It's not exactly symmetric. It looks like if we draw this line in here, that we could fold it on top of each other. Not exactly, but approximately symmetric. These two down here are both skewed. And you can see sometimes I like to actually draw a little curve over. What we have is a left skewed and a right skewed. And the way we decide if it's left or right skewed is which way is the tail going. So we have these tails that come out here. The tail goes to the right, it's right skewed. Tail goes to the left, it is left skewed. Some unusual characteristics that might exist if we look at this distribution on the right. We have this big gap in the data where there are no bars, so that's an unusual characteristic. This data point out here is a potential outlier. I'm going to talk about calculating an outlier. And then if we have like multiple groupings, we would call them clusters. I don't have an example of clusters here. I can show you one if you want, but it's where we would have maybe multiple groupings of data that are separated. When we talk about center, we are going to typically be referring to either the mean or the median. And I wrote them this way because when we have an approximately symmetric distribution, we are going to want to refer to the mean. When we have a skewed distribution, like this one is right skewed, we would want to refer to the center as the median. And we'll talk about calculating those. Similarly, when we talk about how spread out the data is, when we are talking about a approximately symmetric distribution and we want to talk about how spread out the data is, we are going to use the standard deviation. I'm using a little shorthand, so it's important to listen and watch. When we're talking about the spread of a skewed distribution, we are going to talk about this thing called the IQR, the interquartile range, which I will talk about specifically in a minute or two. So we like to talk about how these things are shaped. We want to talk about any unusual characteristics that exist in these distributions that might be interesting, like outliers or big gaps in data, or if we have a couple groupings of data we call clusters. We want to talk about where is the center? Center is like an average. Where is the center of this data? On average, where are all these data points typically falling? And then how spread out is this data? Is it tightly packed? Do they span a large set of values? And then we get specific about the measures of center and spread that we'll talk about depending on the shape of our distribution. And we are going to talk together in class about calculating these measures of center and these measures of spread. So if you're wondering how you get those, we will talk about those together and show the calculator steps. Another type of display we have are called box plots, sometimes box and whisker plots. I have 4 side-by-side box and whisker plots here. You can see they quite literally are boxes with these sort of tails on the end that we refer to as whiskers. The box and whisker plots show us important information. They show us the median. That's this line in the middle, which I'm going to refer to as MED. They show us the third quartile, Q1, and the third quartile Q3 and the first quartile Q1. They show us the maximum value, and they show us the minimum value. We often refer to this as the 5-number summary, which I will show you how to calculate as well when we do some calculator stuff together. And so what this really does is it shows you, if we were to break all of the data points up for this data set where we're talking about Starbucks, from the minimum to Q1, that represents 25% of the data points. Between Q1 and the median, that's 25% of the data points. Between the median and Q3, 25% of the data points. And between Q3 and the maximum, that represents the last 25% of the data points. So the box represents half, or 50%, of the data points. Each whisker is 25%. So IQR, interquartile range, tells us how far apart are the middle 50% of the data points. And we typically use IQR if we're looking at a box plot or when we're looking at a skewed data set. And so if I want to calculate the IQR, I can simply take my third quartile and subtract my first quartile. And so if I wanted to calculate the IQR for all of these groups, I didn't read the whole study. You can read the study. The point is, if I want to calculate IQR, we can subtract the value for Q3 minus the value for Q1 and get the IQR. So what I'd like you to do is just to get in the habit of doing that, I want you to pause and I want you to calculate the IQR for each of these 4 scenarios. So Q3 minus Q1. And if you're unlike me and you were paying really good attention, you would notice that the IQRs are already there. I missed that totally. But that's okay. It's good to practice how to find them so you can check your answers. The answers are right there. So this gives us our 5-number summary for each of those box and whisker plots, and then the IQR, which tells us how far apart is the middle 50% of the data. What we can use that IQR for is finding outliers. Outliers, I mentioned, are unusual characteristics in a data set. They are data points that are really far away from the rest of them. And when we know the interquartile range, that gives us a way to calculate if a data point actually is an outlier. What we would do is sort of build fences around a data set. And if a data point ended up outside of their fences, so any data point up here or any data point down here would be considered an outlier. The way that we find those fences is by calculating 1.5 times our IQR. So I'm going to use Starbucks. And I'm going to do our IQR of 7.75 and multiply that by 1.5. It's 1.625. So we're going to say that any data point that's 11.625 unit or degrees above our Q3 and below our Q1 will be outliers. So we find our fences by taking our IQR and adding it to Q3 and subtracting it from Q1. That's going to give us these values that we call fences, and then anything outside of those fences will be considered an unusual point that we'd call an outlier. So these numbers mean any temperature on our Starbucks box plot that is greater than 29.125 degrees would be considered an outlier. Any temperature below negative 5.025 degrees would be considered an outlier. And in fact, these box and whisker plots do not have outliers. And the way that you can tell is that if they had outliers, those outliers would be indicated as a dot or a star, depending on what your output is on your calculator. And so since those don't exist here, we didn't have any. So I do want to show you one example of describing a distribution. And it's important that we get used to writing incomplete sentences. For the sake of time in this lesson, I will document what we should say. We will work on these a little more together. So we want to describe this histogram of sugar content for these cereal brands. And I am going to say, since we can't really calculate right now, let me draw this first. I'm just going to talk about the center and spread that we should use rather than the actual numbers. We will get into problems where we can actually calculate center and spread. This looks approximately symmetric to me. So incomplete sentences, I would say the distribution of sugar content in the 49 brands of breakfast cereals is approximately symmetric. We have two clusters. This is an example of clusters. We have this cluster right here and another cluster right there. And so that might be a result of maybe healthy cereals and less healthy, more sugary cereals. And so some of them have a lot more sugar, and then there's a set of cereals that have much less. Because this is approximately symmetric, we could look at the mean as a measure of center, and we could look at the standard deviation as a measure of how spread out the data is. My guess is that the mean would be somewhere in here around 28 28% of the weight of the cereal being sugar. So again, I really want to express to you that you should be doing these in complete sentences when you do them on your own. For the sake of time, you don't have to watch me write that out in complete sentences, but in class together, we'll make sure that we write these in complete sentences, and we'll work on doing that together. I do want you to try and describe this one on your own. Remember to hit all of the topics: shape, unusual characteristics, center, and spread. You can talk about which measure of center and which measure of spread you'd want to use. Do practice trying to do these in complete sentences, just so that you can reinforce that idea. If you need help at any point, please do ask, and we'll talk about this at the beginning of the next class.